Okay, 5C is all about geometric sequences. B was arithmetic. And I mean, just think about when you look at a sequence of numbers, this one you can obviously see plus 10, plus 10. If you were adding a constant value each time to find the next number, that is arithmetic. All right. Today we're going to get into geometric. That's when you multiply by the same number each time. Now, so I'd focus on this part. A geometric sequence is a sequence in which each term can be obtained from the previous one by multiplying by the same non-zero number. It's called the common ratio because if you divide the second term by the first term, when you divide, you have a ratio. And if we divide each term by its previous, you get the common ratio. Notice that u sub n plus 1 is always the term that comes after u sub n. When you divide, you get r. All right. I wouldn't focus necessarily on this part. We'll get more into that in a minute. All right. So then I'd focus on this part of the formula. U sub n is like our final term. N is the term number. Let me blow this up a little. And then your common formula is u sub n equals u sub 1 times r raised to the n minus 1. So we're going to focus on that formula. So if we have to show that it's geometric, we have to show there's a common ratio. So I'm going to take each number divided by its previous term and show that I get the same value every time. So 4 divided by 8, 2 divided by 4, 1 divided by 2 is obviously 1/2. 1/2 divided by 1 is also 1/2. So we notice that each time I divide, I get the same constant ratio, 1/2. So I can use that to find my general term. U sub n will find every term in the sequence. So I always need my first number. I always begin with u sub 1 times, what am I multiplying by? My common ratio is 1/2 to the n minus 1. Hence, means using the previous information that you just found, find the 12th term as a fraction. That's really important because a lot of times your fractions don't work out evenly, but you also need to pay attention to the format that they ask for. You could have the correct answer, but if it's not in the correct format, you won't get all your points. So using my formula, I'm looking for the 12th term, u sub 12 equals 8 times 1/2 to the 11th. Okay, so think back to chapter 4 when we would have to change everything into base 2. So 8 is the same thing as 2 to the 3rd. 1 to the 11th is just 1 over 2 to the 11th. And we can now combine bases, subtract the exponents, and I'm left with 1 over 2 to the 8th. And to me, that's as simplified as you need to get. If it's a calculator problem, you could figure out what that denominator is, but I don't know that it's necessary. Okay, this example is telling you it's a geometric sequence. Let me look just a second. I got to make sure that I have my plus and minus. They're both minus. Okay. Sometimes it doesn't come through when I copy and paste. All right, so if you ever have variables like this and you're like, gosh, I'm just not sure what to do, one thing you can always do, create 3 terms of a geometric sequence. 2 times 4, or times 2 is 4, times 2 is 8. What do we know is true? I'm multiplying by 2, multiplying by 2, right? How do I find that? 4 divided by 2 is 2. 8 divided by 4 is 2. See how this is a common ratio? So if I know that it's geometric, that means I can find that common ratio by taking my second term, dividing by my first term. I can also find that common ratio by taking my third term, divided by my second term. Since both of these equal a common ratio, they also equal each other. We now have a proportion, and we can cross multiply. 2k times 2k is 4k squared, and we have to distribute. So you might want to write, well, I'll just write it this way. When we multiply quantities, make sure you put parentheses around each quantity, and you're going to distribute. Now we want to move everything to the same side. Notice this is a quadratic equation. So this is why we spent time in chapter 4 learning how to solve quadratic equations. So we need to get everything on the same side, set it equal to 0. So recognizing that you're left with a quadratic equation is important because you need to think about how do you solve a quadratic. So when I move my k squared, I have to add k squared to be over with 4k squared, so that makes that 5k squared. It's in equals. 21k plus k is 22k. So when I move 22k over to the other side, it becomes negative. And then I move over my 21, so it becomes positive. So now I have an equation, a quadratic equation equal to 0. My first choice is always to factor. So let's see if that is possible. So in order to get 5k squared, I need 5k and k. Factors of 21 are 1 and 21, 3 and 7. And I need to make the combination to get negative 22. So if I put 3 and 7 in, this makes 7k, 15k. That gives me my 22k, because I'm going to add my factors together. And to get negative, they both need to be negative. Now I need to solve for k. K equals 3. And k equals 7/5. Those are my 2 values that make each factor equals, make the equation equal 0. Now, always go back, notice the directions. It doesn't ask us, sometimes it'll make you plug it back in and find the sequence. This just says find k, and so we did. All right, your note sheets are kind of out of order. I noticed this. So we're going to do section or example 9. So make sure you're noticing that on your note sheets. So there's a couple of options here. To me, what makes sense is actually creating a sequence with 5 terms in it. I get that from use of 5. I know this is u sub 1, u sub 2, u sub 3, u sub 4. So sometimes what happens is we can use the sequence just to help us make sense of the problem. And if I start with -6, multiply by r, multiply by r, I don't know what that r is, and I can get up to 162. I'm going to take -6 times r to the third, and that gives me 162. Then I can divide, and r to the third equals -27. Therefore, r equals -3. Its general term is the first. Let's think about the formula. Our general term is u sub n equals u sub 1 times r to the n minus 1. So I have my r, I still need u sub 1. All right, so if I'm multiplying by -3 going this way, if I need to find my u sub 1, wouldn't I just divide by -3 to go backwards, and that gives me 2. So u sub n equals 2 times -3 to the n minus 1. But it's always a good idea, go back. The general term matches my final answer, and then circle it to make sure that when the grader is looking at your work that they know that's what you mean to have as the answer. All right, the last example here is more of a calculator problem. First of all, notice we're multiplying by the square root of 2. So what we're going to do is put in y sub 1. So go to your graphing calculator, go to your y equals. We need to plug in our general term. That's our first term, u sub 1, times, do not use decimals. Make sure you're using the square root of 2. And since in the calculator we just use x, that's just a variable. And now what you're going to do is look at your table. So go up, first of all, go to your gray buttons. Notice second window says table set. And so go to table set, and you're going to say, I would start the table at 1 because that's going to be my first term, my second term, my third term. And you want your change in table to go up by 1. So going up by 1 each time. Now push second graph, that takes you to the table, and scroll until you find the y value that exceeds 1400. The first value that is exceeding 1400 is 17. U sub 17 is 1536. So find the first term which exceeds, so I notated which term I did and the value of the term. All right, that is section C. Section D is actually, this is all section D is right here. It's kind of using the same type of formula. Notice u sub n equals u sub 0. So notice when it's u sub 0, that's my initial, how much I'm starting out with. This is our real world problems. And so we're going to start with our initial amount, and that's when time is 0. So we're changing the formula just a hair to match a real world problem. So we can use u sub n equals u sub 1 times r to the n minus 1, or in this case we're doing u sub 0 times r to the n. So notice it's going to be the same formula. We're just starting out with some different stuff. So R is our growth multiplier, what we're multiplying every time. N is the number of time periods. And this is the amount after N time periods. I always call this my final, oops, can't talk and write at the same time. Final amount. Okay, so the initial population of rabbits on a farm was 50. Initial, that means our U sub 0. At time 0, there are 50 rabbits. The population increased by 7% every time. Okay, so we got to think about this, because if it's increasing by 7, so 7%, first of all, we need to make that a decimal. Move the decimal 2 places to be 0.07. If I use this amount in my formula, that would just tell me how much it's going up by. In order to get my final amount, my growth rate, R, has to be more than 1. So think about, we actually need to use, this is how much it increases by. So we actually need to use 1.07. This is my starting amount plus the increasing amount. Okay, so let's set up an equation. So U sub n equals my initial amount, 50 rabbits, times 1.07 to the n. And we're just going to plug in values. So 15 weeks, because the time, the growth rate is per week, I'm looking for U sub 15. And one thing that's nice, if this is going to be a calculator problem, I would go in and actually type this equation in for Y sub 1. And then if you go to your home screen, so second, quit, you can literally type in Y sub 1 parenthesis 15, and it tells you the answer. Get the answer is 137.95. All right, so how many rabbits are there? We don't have 0.95 of a rabbit, so there's 138 rabbits. All right, if you're not sure how to get the Y1 on your calculator, there's a couple ways. I would push the green alpha. So first get on your home screen, green, the alpha button, then push the trace, and it gives you all the different Y variables. So you just want your Y sub 1 if you typed it into Y sub 1. This is a really slick way for the calculator to do the problem for you. Or you could just type in the 15 and just type all that in also. All right, then we want 30. So this is for part A. Then, so 50 times that, and that gives us 360 or 380.61 or 381 rabbits. All right, for letter B, all right, so this is where you can do a couple different ways. This might be a good one to also use the table feature. So if you've got your equation, your general equation typed in for Y sub 1, go back to your table. So if you have not changed your table from C, push second window. You want your table setup. I would always start at 1 and go to change in table to equal 1, then push second table, and you want to keep going until you can find up to 500. And you should notice it's going to take 34 weeks. And probably what I would do is actually write what you did, that you used the table feature on the graphing calculator, and that's how you got your 34 weeks.